Alright guys, today we are going to work on the hotspot graphing assignment. Alright guys, today we are talking about hotspots, and you guys are going to do an activity with the Hawaiian island chain. So the Hawaiian Islands are in the middle of the Pacific tectonic plate, and the currently active volcano is the one down at the very southernmost point. So you can see in the larger scheme of things, it's the one down here. So all of these volcanoes up here are much older. So basically the way hotspots work is it's a weak spot in the middle of the continental crust or the oceanic crust that is very weak or has like an unusually hot spot of magma, and so that has managed to melt the crust in that location. And as the plate moves, that tends to form a chain of volcanoes. And we can look and see the age of the rocks that were formed in the volcanoes, and we can kind of figure out which way that plate was moving and how fast it was moving. So if you imagine that my pencil is the spot of really super hot magma, and this is the Pacific plate, so as it moves over it, it gets new spots in the crust pop up a volcano. So the first thing you will need is your map of the Hawaiian island chains, and a ruler and a pencil. So let's get started. The first direction in our procedure says, using a ruler and the map provided, measure the distance between the first volcano, which is Kilauea, and the other island volcanoes. So I'm going to measure from the center of Kilauea to the next one, which is Kahului, which seems to be this one right here. So I'm going to line up the center of the zero line in the middle of Kilauea and do my best. It looks like that next Kahului is about a half a centimeter away, so I'm going to record that here. And then Maui is our next one. So go from the center of Kilauea to Maui. That looks like it's just about the same distance, just a little bit different direction. Half a centimeter away. And then Lanai. Let's see. That looks like it's half, 7/10 of a centimeter away. Alright, so you guys get the idea on that. And then, so you're going to do that for all of the rest of these islands. And then you are going to use the scale on the map and a ruler, and you're going to convert that into all of your measurements from the map into real life measurements or kilometers. So we're going to measure this scale bar on the map and see what you think that is. So it looks to me like it's 4 7/10. Okay. So 4 7/10 of a centimeter is analogous to 1 kilometer in real life, and so we can just set up a proportion to convert these down here. So we know that we have half a centimeter on the map, and we're converting it into kilometers. So the actual distance between the islands, or between the volcanoes. So we can cross multiply. So then we'll grab my calculator here because we're dealing with kind of, alright. So All right, so that's equal to about 1/10 of a kilometer in real life. We can also just set up an equation here and say that our map measurement, so our distance in centimeters, map measurement divided by 4.7 will give us our actual distance. You should measure and make your own conversion rate. All right, so we're going to continue with that, and then we're going to move on to spreadsheet. All right, so our next direction says that, all right, so we need to finish converting all of our measurements into kilometers using the scale on the map. So I put all of my data in a spreadsheet because we're going to need that anyway later. And I rearranged some of the columns in the table. So if you read down here in step number 4, we need to have the age in millions of years on the x-axis. So that's going to be in column A, and the distance in kilometers on the y-axis. So that's going to be in column B. So I put these two columns in column A and column B, and then I rearranged the others. Okay, so these are the distances that I measured on the map, and you guys will do that on your own as well. And then I used that calculation that we did to figure out. So I did the map distance and then divided that by the distance in the key, and that gave me that number in kilometers. So if I want to apply that to all of these different measurements, I can just, after I've put that formula in this cell, I can just click on this square in the bottom right hand corner and drag that down, and that'll apply that to all of my data. We don't have that precise of data, so we're going to remove some of our significant figures by decreasing the decimal places. We'll go with about 2 decimal places there. So these are our distances that those volcanoes are in real life, more or less. All right. So, all right, we already set up our spreadsheet, and our note here says that we will have to remove the error from the age values. So 0 to 4 million years to 4/10 of a million years will have to be converted into 0, and then we'll have to convert this to 1.3. So let's go ahead and do that. So we're just taking off all of these error values here. Because when we do carbon dating, it's within a range. We can't get it perfectly exact, but it's within a pretty close range. All right. And we're going to change this just to simplify our graph to say age. So now we are going to create a scatter plot. So we want to graph this data here, and we want to create a scatter plot. There we go. Age is on the x-axis and distance is on the y-axis. That's what we wanted. All right, and so now we need to add a trend line. So we're going to go to Series and click that drop-down menu, and then we're going to add a trend line. And to help us see what will fit our data best, there we go. There's our r² value. So the closer that value is to 1, the better that that line fits our data. Here, that was a pretty good fit, and that'll make our lives easier later. There we go. We want to use our equation as our label for that line. So the reason that we are measuring from Kilauea is because Kilauea is the currently active volcano, so it's the youngest volcano in the Hawaiian island chain. Alrighty, that looks pretty good. Okay, and so now we are going to insert our chart, copy our chart into our template there, link it to the spreadsheet in case you make any changes. Make sure you put a description of what your graph is showing. Or something like that. And then you're going to answer some questions down here. Make sure that you pay attention to the last set of directions. So the slope of your trend line is going to give you the speed of the plate, so of that Pacific plate in kilometers. And then you're going to have to convert that speed that you got from the slope of the line into centimeters per year. So figure out how to do that with some conversion rates. All right, so let me know if you have any questions, and that is how you do this assignment.